All right, combinations. That's the lesson for today. Let's get into it. A combination is a selection of items R from a set N where order of selection doesn't matter. And you notice that I have gone through and made Rn order doesn't matter yellow so that you see the difference between combinations and permutation. And in order to get the formula, I'm going to go walk you through a couple of review questions and then we're going to set up the formula. All right, so example 1a is a review. How many possible selection of two letters can be made from the set of four letters A, B, C, D if order matters? So this is a permutation and we've done this before. So the NPR is very simple. You have 4 factorial on top. You want two letters, so that would be 4 minus 2. So basically N is 4, R is 2, and then you will end up getting 4 factorial over 2 factorial, and then that would be 12. Okay, so there are 12 ways, 12 possible arrangements or selection that can be made. Very good. Now, order matters. What does that mean? That means if I write down A, B, C, and D, that's different than saying B, C, D, and A. Obviously, they are. But in combinations, it doesn't matter. It doesn't matter which one comes first, which one comes second. So what happened is that in a situation like this, if you want to find any two letters, AB and BA, they're actually the same. So in combination, order is not important. Very good. So when you see this, you notice that once we get this total arrangement selection that order matters, we have to undo or get rid of all the number of arrangements in which the order mattered, because in this case order doesn't matter. So how many ways the order mattered in here? Well, there are two letters. So if there are two letters, that means AB will be different than BA, right? So if that's the case, we have to get rid of 2 factorial ways out of the total number of permutation. So in terms of the combination, we'll get the NPR, which is the total permutation. We have to divide it by the R factorial. So in our example on top will be 12 divided by 2 factorial will end up being 6. So how many different ways the two letters can be made from a selection of 4 letters? It says order matters. That is when you have a permutation. But if I say order doesn't matter, then you will get 6. And that is the example B. So in example B, same question, but this time order does not matter. And if it doesn't matter, we have to not double count the arrangements in which order matters. And in this case, we had 2 letters that order matters in that one. So we have to undo that. We have to discount that. And to do that, we have to divide the total number of permutation by the number of repeated selection in which order matters, which is in this case 2 factorial. All right, so now we're going to put the total formula in. So this is how the notation goes. N choose R, that's a C for combination. And by the way, there's another way of writing it, and it is like this in a big bracket like that. And the formula for that is n factorial divided by r factorial times n minus r factorial. And notice that notice that this is the permutation formula. Okay, and this r factorial on the bottom. So that's what you're going to use, and we're going to go through a few examples. Let's do that. Okay, first example in combinatorics. How many five card hands are possible in a regular 52 card deck? All right, so we have n is equal to 52. We have r is equal to 5, and we can easily write up the combination formula. This is 52 choose 5, which is equal to, and then you go ahead 52 factorial over 5 factorial times 52 minus 5 factorial. And that's very simple. You take out your calculator, and when you get that, you'll end up getting a number that is huge. That's 2,598,960 different card hands you will have. That's a 5 card hands, okay? All right, very simple, and you just go through it and then plug it into a formula, and then you'll get that. By the way, some calculators, they even have the combination and permutation key. So you just have to punch in 52 and 5, make sure you don't mix them up, and then you're gonna get the answer. But be aware that you, in most cases, in exams and in tests and quizzes, and even in projects, you do have to show this actually expanded form without before punching into your calculator. All right, let's look at the next one. Here it is. How many different lotto tickets are possible when you choose 7 numbers from 1 to 49? And it's very simple. And by the way, these are Lotto Max in Canada. I'm in Canada, so here it is. Again, let's write it up. 1 to 49. So we have N is 49. We have R is 7, and it's very simple. You just have to, again, do 49, choose 7, equals to 49 factorial all over 7 factorial times 49 minus 7 factorial. Now, when you do the math in this one, you'll notice how many different lotto tickets are possible given the specifics here, and the answer is, and here it is, 85,900,584 different lotto tickets. So you can see if you buy a lotto ticket, a set of 3 tickets, 3 lines, 3 set of 7 numbers for $5. Okay, so you have to divide this by 3, so this comes out to be about 27 million, around there anyways, on average 27, 28 million. 1 in 27, 28 million probability of winning. That's why it's astronomical. All right, so this is the example 2. Let's look at one more example, and that is it. From 5 soccer players and 4 coaches, 3 players and 2 coaches were chosen to attend the training. How many ways is this possible? Okay, so there are 2 different things that we got to deal with, and there are 2 different combinations. First of all, we got to deal with the players, and then we're going to deal with the coaches. So out of the 5 players, we need 3 players to go. So this would be, the first one will be the 5 choose 3. We have to work through. We have to find out what that is. Then we have to work through the 4 coaches. We need 2 of them. So that would be 4 choose 2, and that is for the coaches. Okay, so this is for players. Now, to get the total possible numbers, we have to multiply them. That's what you have to do. All right, so let's go ahead and do the math on that one. And that's just simply, you put them all together, you get 5 factorial over 3 factorial times 5 minus 3 factorial times, and then the top one will be, the other one will be the coaches, will be 4 factorial over 2 factorial times 4 minus 2 factorial, and then you take out your calculators and find out what the answer is. Math, you get 10 times 6, and that would be 60 possible ways that you can send 3 players and 2 coaches to that training sessions. All right, I hope this was useful. Check out the next video. Until next time.